Hey guys, welcome back to the next video. In this video, we are going to work with the part number 13, and this can take a lot of patience for you to complete it because I, I was troubleshooting a lot to replicate it. I've done it on my production environment on servers, but then to replicate it on my laptop, it took a fair bit of time to clear all the errors and exceptions, and I had to redo this video like 3 times because there was just too much of errors. But finally, the good news is that I was able to resolve it, and I will be able to showcase you this dynamic configuration here. Now, the only way to appreciate me for all the efforts I'm taking towards creating this wonderful training is by giving a genuine review of what you feel right. A written review would be advisable, and it would be nice for me to, and it would encourage me to create more such videos with with real-time scenarios and projects, which is towards this kind of problems, which none of the other trainers does share all these things. All right, without no further ado, let's just jump into this video. So firstly, we have understood on the previous video about the architecture. So we're going to go with the game plan, which was decided on the previous video. So I'm going to create a P13 over here, which is going to have my part number 13, which is on your GitHub. The first file I'm going to create in P13 is the role-based access control.yaml. So now what's this file? As we are going to use a service account on our next video, on the next YAML file. So we want to define some privileges for the service account. So I'm giving that service account name over here. And every time I give that, I give roles. Okay, roles are, we will have a separate session to talk about authentication and authorization in terms of Kubernetes. But just to give you a heads up on that, right? So let me just give you more space for you to see it. So this is a service account creation. So what we're going to do is like, we're going to use this name as metadata. This is the service account name, NFS client provisioner. So this is the one in the next video, next file, which we're going to modify. You will see the service account name, which will have the same NFS client provisioner. So what we are going to do here is that by default, to create any kind of authentication, right? So we need to follow this. So not just in this scenario, but any scenario for that matter. If you're adding new feature to your existing Kubernetes would not understand that, because by default it all says no. So we have to include everything whichever we are creating newly and say yes for those things which you are including it. So this is one of those things which we are going to include. And this is a service account creation, and this is happening on your namespace, which is default. So the first one is that we are going to add, this one will add the service account. That's the first thing. And second thing is like, this is going to add some cluster roles over here. And that's basically what cluster role is, this one, NFS client provisioner runner. And then what rules you want it to run. So you just give it that one, and then you see that the cluster role binding, and we are giving this one NFS client provisioner, the same service account details we are giving. Likewise, we are giving permission to your roles, role bindings. Likewise, we are giving all these permissions like get, list, watch for the endpoints. And then here we are giving it for persistent volume claim, events, storage classes. So using this particular name, I'll be able to get, list, watch, create, delete. So this is kind of all permission, which is required for me to work with persistent volume claim using this service account, this name as a service account. So go ahead, save and quit this file. The next file is going to be P13. storage-pr1.yaml file. So this pr1 represents, it's going to be the provisioner, and that's the file which I want to copy paste the content which is on my GitHub. Now do remember, this content is basically a deployment. So now I have fine-tuned this a little bit adjustment over here. So the deployment name, the kind is deployment. The name is NFS Client Provisioner, and the label which it is looking for is also, label which is attached to this deployment is NFS Client Provisioner, and this is going to be deployed on the default namespace. So you need to attach this in the provisioner's namespace. By default, all our deployments and everything which is going on is on the default. So I'm just going to leave it as default. Number of replica for this particular deployment, I just need one. I need this to be on the recreate type strategy type. And then it's going to match the selector which has the name of NFS client provisioner, which is obviously will be the name of my pod as well. So that's the name of my, that's the label of my pod, which is going to be having the app value as NFS client provisioner. That's what it is matching over here. The next one is about the node selector. So this is a new parameter you've not seen so far. A node selector is an option where you want a specific node to run on a specific node. Like for example, when you do kubectl get nodes, right? So you will see manager one there. So that's a control plane. So I want this to be running on the manager one, which is the control plane. So I'm giving that one over here, saying that I want this to be running on this host. The next one I'm giving here is a service account name. This is going to be NFS client provisioner. So this is the one which you have defined on the previous file, and that file had the service account definition for the NFS client provisioner. Here, the container name is also the same, and this is the location where it's going to download the image from. It is called NFS subdirectory external provisioner. So this is going to help you to provision your external NFS for your dynamic volume. So here volume mount is going to be mounted on the NFS client root, which is going to be your /persistent volume. Now let's talk about the volume name in the bottom. So let's go there. But before that, we have the environment variables. In the environment variables, which is the whole purpose of this, existence of this particular deployment, is this one. So this is how your storage class is going to load it. So when I give this value as a provisioner name, so this is very important for us because this is the value, this is the only value we will give it on the storage class. The moment you give this on the storage class, you don't have to give anything else because everything will be loaded from this file, this deployment, because this is what it will look out for, searching for any values like this as an environment name for the existing deployment. And when it looks at this value, it picks up the NFS server name, it picks up the NFS path from here. You don't have to really define it. But then for this deployment to work, you need to give the volume defined like this. Okay, so this is going to have manager one and NFS location on the NFS client root. Now, why it is having like defined manually? Because this needs to get the deployment done. This is the first thing you need to start. The first thing which you're going to do after your role-based access control, if you run this YAML file of creating a provisioner before you run the role-based access file, you will see that the pod will not be created. Why? Because the service account does not exist. It doesn't have permission. So it won't even create the pod. So first run a role-based authentication, then run this guy over here, where the NFS will be actually mounted to this location in the persistent volume, and then this particular image will start. If this image doesn't start, then storage class won't start. If storage class doesn't start, then persistent volume claim won't start. And then your deployment, which you're going to do at the end of the video, will not work. It will all be in pending state, one after another, if one fails. So that's why it is very critical that you should understand what I'm doing and follow the hierarchy. Yeah. So what I'm going to do right now is that I'm going to use this volume, my NFS volume, to mount as part of this particular image and make sure this is available. And once this is available, my image, this particular container and the pod will come up eventually to the ready state, and that pod or the container will be hosting these items on the environment variable. Then my storage class will make sense. It will able to identify this guy, and it will take the values from here and start working with your PVC. And when you create a PVC saying that I need this much of a space from this volume, then you will be able to provision your pods where you will be running your Nginx image, right? So this is a hierarchy. So let's just go to the next step, save and quit this file. The next file I'm going to create is storage class. Now here in the storage class, I'm going to have the storage related definitions. So look at this, what I'm going to paste here. I'm pasting very simple configuration here. So one is the kind, which is a storage class, which is the kind. And here I'm talking about NFS storage class, which basically the metadata name, which basically is the name of the storage class. And then you have the provisioner. Now this provisioner name will match the provisioner name on your provisioner file. If it doesn't, then it won't work. So this name, which is given over here, provisioner name, which is K8-sign.io, and then the subdirectory external provision name, and what is given on the class name. You can see that it matches. So K8-sign.io/NFS subdirectory external provisioner. So that's basically matches. The second option here I'm giving is like allow volume expansion is true, which means that my PVC, I can expand my volume, and it will let me expand my volume if it requires. Reclaim policy is retain. You can also make it delete, where if your PVC gets disconnected or deleted, the content will also be deleted, and it will not be there if you have selected delete. In terms of retain, it's gonna retain the content, and you can reissue that PVC, and you can claim that location again. Save it with this file. Now that the file is getting done, let's go to the next one, which is where you will create the PVC, which is your persistent volume claim. In your persistent volume claim, you will be actually adding the actual size which is required for your for your pods, which is going to be assigned as part of the PVC. So here, a very simple configuration. Your persistent volume claim is the kind, name, NFS PVC, access mode, it's read write once, storage class, NFS storage class. That's basically I'm not sure if this is the right name, so let's compare the storage class name, NFS storage class. Yes, the name of this is correct. So yeah, I guess I made a mistake there. So this is perfect. So NFS storage class, resource request storage, I'm requesting for 5 GB of data. Perfect. That's completed. So let's go and create the next file, which is your actual pod, which is the mind of the whole reason of you being here, right? So that's your story. That's your deployment. Though it's named as pod, ignore me. It says deployment. A simple deployment over here, which has one replica, and NFS app is the name of it, and the pod name is also labeled as the same. And you can see it's an Nginx image, and this NFS volume is mounted on the NFS share Nginx HTML. And this whole thing uses the volume with the persistent volume claim, which has the claim name of NFS PVC. That's a claim name over there. So save and quit this file. Very simple file. There's nothing new here. Now comes the execution. So this is where it gets tough. All right. We may need a little bit more because there's plenty of things which is gonna go happen right now. So let's just do a kube control P13 first, role-based authentication control, and YAML file. Just gonna do apply -F of that. And you can see that this looks unchanged. For you, it may be like changed or created. It could be any of those. Once it is done, we are good with authentication. So we should be able to execute the next file, which is your storage pr1.yaml, which is going to create your provisioner. Now you can see that provisioner is created. So now it is currently coming under pending state. Now we just need to wait for the pending state to get assigned or created. Now we have asked it to create it on the master node. So maybe that's the reason it has gone to pending state. So let's just look at the logs over here. So let's just kubectl describe. So it seems like it is an untolerated node. So that's why it's not able to create it on the first node, because it is deemed as untolerated to have this. We will talk about this later, but then what I'm going to do is I'm going to remove this deployment. Sorry. Yeah. So what I'm going to do is as of now, I'm going to remove that parameter because it's not working. And we have to remove the untoleration, but that will take some time, and which is unwanted complexity at this moment. So just going to remove this and going to run this again. Yeah, it should be created now. It should be running anytime. Yeah, it's already running. So I'm going to remove it on your document as well as part of this configuration, so that doesn't complicate you, because until I talk about the toleration, right, I don't want to talk about this one. Perfect. I've got that removed for you guys, so you should be good enough to proceed further. Yeah. So next thing we are going to do here is the kubectl apply -f p13. The next thing we are going to do is storage class over here. Now storage class will be using the provisioner, so we have to see how well it adapts to this command. So let's just execute this. You can see now it is saying the storage class is created. You can see the storage class name. You can see the provisioner name, which is basically this guy over here, which is the provisional name which is declared inside of it. So it's not something which is something you can see over here. You can see the reclaim policy as retained, and volume binding mode is immediate right now. What that means is it is waiting for something to take the connection. It's just waiting for something. So then let's not make it wait any further. Let's just process the PVC. Now you can see that PVC is created. It is saying in the bound state. Okay, so this is PVC. And this is, you can see what is this, persistent volume it is. Okay, so this is the PV I was talking to you about. Now the persistent volume is equal to the persistent volume claim. So now, as you have not defined the PV explicitly, but the persistent volume claim, when you declare it, it basically, the persistent volume also comes over here, and it has the same exact configuration as your PVC. Now previously we defined the PV and then the PVC with the same details, and then it was able to create both and then start the communication. But here it's a little different. So you create PVC and PV will be automatically created, and the PV creation will be in this method. It will say PVC hyphen a unique ID over here, right? Now this unique ID will be created. It will be created for your PVC. But only way to differentiate these two guys is by looking at the actual name of it. So it says persistent volume here. It says persistent volume claim here, right? And this is what we have created. And it is assigned to PV. So that's how it needs to be done. Okay, so you can see the volume name as the PV persistent volume over here. The capacity is the same, access mode is the same, and you can see the retain is basically taken from your storage class. It is not taken from here because we don't define anything like that in PVC. So it takes values from both these guys. Okay, so you can see pretty much all these guys are bound, so which means that it is all bounded and working fine. The last and final piece is to deploy your pod level. Now this is why we are here for. Let's see if this works fine. Now you can see the container is getting created and container is running. Now what's happening right now is that your Nginx is started. So when I do a curl of this particular IP address, which is where, oh, sorry, that's not the one. This one over here in the first deployment. So this is should be returning us Nginx page is 403. Obviously, we want the 403 right now because we don't know where it is writing the data. Now go to MNT NFS. Now you will see a new folder created over here. Now when you see that, examine the folder name over here. So you can see that it has default, which is your namespace, NFS-PVC, which is basically your, your PVC name, which is given over here. And then PVC-05CE1, which is basically your PV name. So PVC-05C61, blah, blah, blah. And then that's basically the folder where this particular pod is mounted on right now. So if we just go inside this folder, you will see the files here. So when I do a cat of index.html, we're like, hello, this is storage class test, and then do a curl command again with this IP address. You can see that it is returning back. So you have created a file which is within this folder, which is created because of all these work which we have done so far. And that has actually resulted in this particular file. All right, so I think pretty much this is what I wanted to cover on this video. And in the next video, we will see some advanced concepts over here. Before we begin with the next video, we will also do some R&D. I'll show you how to remove all these things. What is the hierarchy in terms of removing them? And those advanced things, we will see it on the next video. And if you have any questions at any point of time, and if something is not working, please do let me know on the question section. Please come up with some description and logs of each items, so that I can understand what you're trying to do and fix your problem much faster. Thank you again for your patience and time. I'll see you on the next video.